The trapezoidal rule is a way basically to find area underneath curves without having to do integration. Reasons why we might want the area between the curve and the x-axis could be calculating total distance travelled if we have a velocity time graph, or the amount of liquid obtained if we have a rate of flow versus time, or the balance of a bank account if the rate's not constant. Okay, so whenever we're trying to do something that would normally multiply, like find the distance travelled would be velocity times time. If that velocity is not constant, we would have a velocity time graph, and we would find the area underneath. Okay, basically finding the distance or whatever quantity it is. So I've got a few methods that we can use for that. We can use these rectangular methods, which we're not really going to touch in this course. If I wanted to find the area under this curve between 1 and 5, I could look at how high is it at 1, how high is it at 2, and then start drawing rectangles. Okay, all the way to how high is it at 4. Okay, and this area should be pretty close to the area under the curve. Imagine if I had more rectangles, it would get even closer. In a similar way, I could do it using the upper rectangles. I might end up with a little bit more, but again, more rectangles should be okay. The trapezoidal rule is probably the one that we'll focus on. Okay, the whole idea of trapezoidal rule is to break this section up into trapezoids instead of rectangles, so we get a closer approximation faster. If I was to label these sides A, B, C, D, and E, okay, and note that they've got a distance of h between them. If I wanted to find the area of T1, it would be h on 2, A plus B. If I wanted to find the area of T2, it would be h on 2, B plus C. Okay, and I could do this all the way through for the 4 trapezoids, just using your normal trapezoid rule, okay, of a half A plus BH. So we'll see what's sort of common here is that we've got the common h on 2. If I wanted to add all these together, I'd have h on 2, which is common to all of them, and then A plus B plus B plus C plus C plus D plus D plus E. A way of simplifying this is to say, well, these two are the endpoints, okay, the end distances on the side, add them together, and then any ones in the middle, add them together twice. So if it's in the middle, add them together and multiply it by 2. And instead of using h, we'll use w for the width between them. Okay, if that made no sense at all, doesn't matter. You can just focus on applying the trapezoidal rule. Okay, this is what it looks like. So the area underneath the curve is the width, w, between the trapezoids, divided by 2, multiplied by the endpoints plus 2 times the middle points. So I'll see how this goes with a few examples. I've got the function f of x equals x squared, and I'm going to try it with just one strip to start with. I'll write down my rule. The width divided by 2, the endpoints plus 2m. Using just one strip, I'm making it all into one big trapezoid. So all I have is these two distances, these two endpoints. I don't have any middle points. I know that the width is 5 minus 1, which is 4. Okay, to find the sum of the endpoints, I'm going to need to know what this height is and what this height is. The way I'll do that is I'll find what f of 1 is to find the height here. My function is x squared, so I'll just square it and get 1. Okay, I know this height is 1. Do the same thing to the other side. find what f of 5 is. I can square 5 and get 25. So this distance is 25. And I know that these two are going to add together to give me my E. Alright, I know that M is 0 because there's no middle. So I can now substitute in and find the area. Area will be 4 divided by 2 and then 26 plus 0. So I'll end up with an area of 52 units squared. Okay, because I don't have any dimensions on either of those axes. So that was one strip. Just by looking at the graph, we can probably see that's overestimating because we've got this big section in the middle that we've calculated the area of that's not actually under the curve. So we'll try and improve on this and use 2 strips, which means that I now have 2 trapezoids. 1 and 2. So the formula is going to be the same as in the first example. Okay, however, the width of my strips, the horizontal distance is still the same, 5 minus 1, but I've got 2 strips, so I'll divide by 2 to give me a width of 2 per strip, which seems right because this distance here is 2. To find my E and M values, I'm still going to need to know what these 3 heights are. So I need to know what f of 1 is, I need to know what f of 3 is, and I need to know what f of 5 is. So if I wanted to, I could mark these on. This is 1, this is 9, this is 25. So my E value is just the endpoints, 1 plus 25, and this is my M, my middle point. So from here, I can substitute into my formula. My width was 2, so 2 divided by 2, 26 plus 2 times 9. Okay, which will give me 44 units squared. Okay, which is lower than the first estimate. However, I think we could still do a bit better than that. We can still see that there's these little areas in here which aren't really included. So I'll finally try using 4 strips, see how I go. Again, I'll find the width. The horizontal distance is still 4, but I've got 4 strips, so the width is 1. I'm dividing it into these 1, 2, 3, 4 strips. So I need to know what f of 1 is, what f of 2 is, what f of 3 is, what f of 4 is, and what f of 5 is. Again, these 2 endpoints, I'll write these on actually so I can visualize it. They're all my heights. The endpoints will be 1 plus 25, okay, so again 26. And these 3 in the middle are my M value. Okay, you can see them there, literally in the middle. 4 plus 9 plus 16, that gives me 29. So again, I can find my area. Area is W on 2, E plus 2M. And I can substitute in my values. Width of 1, endpoints is 26, and I've got 2 times 29. Okay, I'll still put it underneath. Gives me an area of 42 units squared. So it seems to be decreasing as I get more and more strips. I can obviously compare this to what I know the real result to be. So if I was actually integrating this, between 1 and 5, let's have a look at what the integral would actually be. I get 125 on 3 minus 1 on 3, which is 124 on 3, okay, which looks like 41 1/3 units squared. Okay, so even just with 4 strips, we're getting pretty close to what the real answer is. Okay, the more strips, the better. You need to find what the width between the strip is, find what the height of all the strips will be, and then you can use the trapezoidal rule to find the area. Here's a whole heap of questions to have a go at, split between knowledge questions and modeling problem solving questions.